Hi, everybody. Thanks for coming. 6 in the evening. It is a pleasure to introduce Dr. Mehta. Maithili?
Dr. Mehta is fine.
Mehta. I've known Mehta for many years now at UQ, and UQ has known her for longer. Mehta finished a PhD here in 2003.
Yes.
In mathematical physics. Has anybody done any course in mathematical physics? Okay, well, more than one. She doesn't do mathematical physics today. I think we'll hear about that. But she came out of here very smart, or probably was before. So Mehta has been a close collaborator of the School of Math and Physics from the industry perspective through our industry summer internship program, through reviewing our program, and also through creating this course and discussions for this course. And yeah, one of Brisbane's vibrant software professionals, and we'll hear what Mehta has to say. Thank you.
Always interesting to hear what other people say about you. So nice to meet all of you guys, and stop me at any time through this if you have any questions. Let's keep it pretty informal. Is this going to go to the next slide? Okay, I think I've probably skipped to 2. All right, so just a little outline on what I'm going to go through. So I'll tell you a little bit about my background, my career, a little bit about each different workplace I've worked at. I'll tell you some stuff about what it's like to be a software engineer. And then I've got like a little section on employee attributes, because I think a big thing going from like uni and research to a job in something like software engineering, it's quite different, and what you need to do and what the expectations are quite different. So, some of my slides blocked. Hang on, I'll just move this slightly down and this slightly up. I'm probably going to have to move these every slide anyway. So how did I get into maths? So I know that a lot of people don't really think of maths as a career. I'm guessing nearly everyone in this room does, but the way I kind of got here is that pretty much every adult in my life when I was a child was a mathematician. So my uncle was a mathematician, my dad was a mathematician, my mum was studying maths as well. In fact, I did a bunch of subjects with her, which was very handy. When I didn't go to lectures, I could get the notes off her. That was nice. So when I kind of got to like the age where I was starting to learn to read, instead of the normal ways that kids get taught to read, you know, Dr. Seuss, The Cat in the Hat, all that stuff, my dad and my uncle thought it was a great idea to teach me how to read by getting me to read the titles of their maths textbooks. So I was like, 3 years old, talking about vector calculus and algebraic geometry. And I used to tell everyone, they'd say to me, what do you want to be when you grow up? And I'd say, I want to be and I'm saying this how I used to say it when I was 3. I can pronounce all of these words now, but I said a professor in algebra and topology. So a little bit odd. And my parents my dad used to teach me probability when I was about 6 for fun. So by the time I got to school, I kind of had it a little bit easy there. I think I went through a brief phase of wanting to do something besides maths, but it was stamped out very quickly at home. So I actually started at University of Queensland when I was about 3. So I actually went to campus kindergarten and went to Ironside, and then went to Brisbane State High, and then made my way back to UQ. So I've been hanging around here for pretty much my entire life. And I did, my undergraduate degree was in pure maths. And then I did honours in partial differential equations. And then I decided to do a PhD because that's kind of what you did in my family. Everyone, between me and all my cousins, we could probably start a university. And my dad actually has 2 PhDs. I have no idea why, but he has a PhD in economics, and he taught at the economics department. And then he decided after I was born, to do a PhD in maths at the maths department. So, the sky's the limit with study. Like, you can keep going if you want to. So I was doing a PhD, and I was coming to the end of my scholarship money. And I was like, how am I going to support myself? So I put feelers out for jobs, And because Brisbane's Brisbane, my mum knew the wife of the director of a company that had been started by 2 maths professors. And coincidentally, also my best friend worked there, and they had an opening. So they said, I'll come in, we'll interview you. And I said, okay, but I'm going traveling in 6 months. I'm only going to take the job for 6 months. And they offered me a job in software testing. I had no computer experience at all, none. So all I had done, like I typed up my PhD in LaTeX on a Linux computer in the department, and that was it. That was all I could do. I couldn't even turn on or off a Windows computer, just to give you an idea of just what a transition this was for me. Anyway, so I took the job, and I didn't end up moving overseas. 6 months later, I ended up staying in the job for, I think it was like 17 years. I stayed in that job. And after about 6 months, they said, oh, we think you'd be really good at programming. So they sent me on a 1-week C++ programming course. And then I ended up doing like all their algorithmic coding for like a really, really long time. And the company kept getting sold. So it started off as Opcom, and it was actually run by Michael Forbes, who's in the department now. Some of you may know him. So I worked with him for many years. And then it was bought by a Swedish company called Carmen. Then it was bought by a Boeing subsidiary called Jefferson. And then it was finally bought by Silver Owl. And the company worked in journey planning and ticketing software. So their first customer was Transinfo in Brisbane. And then their subsequent big customer was in the UK. So doing like train tickets for the UK, which sounds not that complicated, but it actually is super complicated. I'll explain more in a bit. Then I went from there to a company called Deswick, which does mining software. And I ended up getting that job because I'd worked with someone who worked at Deswick, and they said, we think you'd be great at Deswick. I went for an interview. I said, oh, it's not the right time for me to move, blah, 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 blah. Went back for an interview 2 years later. They offered me another job. I said, oh, it's still not the right time for me to move, blah, 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 blah. And then 3 years later, I went, would you like me to come on board? And they were like, yes, please. And so I went and worked there for a little while, and then went from there to the company I work in now, which is called USmartThing. And it's journey planning again, but with a specialization in events and travel. So the idea is to try and manage travel around big events. So big things like the Commonwealth Games or events at Suncorp, so that you can manage the network traffic around the event and around the venue, and hopefully avoid people getting stuck in traffic. So I told you a little bit about how I started working there. And through my time at Opcom, Carmen, Jefferson, Silver Owl, all the different names it had, I worked as a tester, a software engineer, a support manager, a team lead. And none of these things were things that I had learned to do at university, because a few of these jobs didn't actually exist when I went to university. But they were all things that my kind of background in maths and what I'd done at uni really prepared me for. Like I was able to learn stuff really quickly, understand the industry problems, understand all the different data that we needed to deal with. Learning to code was surprisingly, I guess, easy, given that at uni I had hated computer science. Like I really, really didn't like it, didn't really get what it was for. Was sort of like, what am I going to use a computer for anyway? It's never gonna catch on, these computer things. I was kind of wrong. But then when I actually started working at Opcom, I found the problem so interesting, and it was really cool to be able to use coding skills to solve them. So I think that's kind of one of the things I learned, that once you've got a little bit of perspective and context around the problems you're trying to solve, it suddenly becomes really fascinating and really, like I just love it. So this particular company was medium sized. So there were about like somewhere between 20 and 50 people in Brisbane, but it had an international presence. So sometimes got to travel for work. There was like a London office and a Boston office and all sorts of offices all over the place. And through my time there, I worked in C++, C#, Java, Python, Perl, React, Redis, Docker, AWS, Kubernetes. Like there were loads of different technologies that I was able to get involved in and work with. So Deswick, I knew someone and they thought that I'd be good, and they got me to come in. Mining companies generally love mathematicians. There's lots of really deep optimization problems to solve at a mining company. And then there's also some stuff that I didn't, until I worked there, I didn't understand anything about mining. So I kind of came in there with no industry understanding at all. Didn't know. I think the first few weeks I was there, I did a course and I learned all about explosions and you'd blow this up and blow that up. And everyone else was much more excited about the explosions than I was. But yeah, it was kind of interesting to see that. And there's a lot of really difficult problems around the graphics. If you look at that picture, for example, looks kind of funky, like it's not a great graphic, but this is kind of what they have to work with to visualize the mine. So there's a lot of potential of really interesting kind of graphics problems there as well. And then huge data. So they have to sometimes dabble in unsafe C#, which if any of you have any experience of C# is a pretty kind of, the word unsafe says it all. It's a pretty like, whoa, why would you be doing this kind of thing? And playing around with actually like hacking into the file system of your computer so that you can look things up from massive files very quickly. So there's some really kind of interesting things in there. Use smart things. So again, this was another, I knew people who knew my work and knew what I could kind of do and what I kind of understood. So I was approached by the COO of the company who I'd worked with before, and he asked me if I'd be interested, and I said yes. It's a UK-based company, so I was the first Australian employee. I'm the lead of software engineering and innovation there, and it's a very small company. So Deswick was massive. My first company was medium-sized. Deswick was really big, like 120 developers all in the same code base at the same time, which was just nuts. Like, you know, you'd get the code and then 1 hour later it was completely different or broken, often just broken. And now I've gone from that to managing a team. There's like 6 developers and we're like half of us are in the UK, half of us are here. We've got 1 person in Istanbul. So it's a very different kind of vibe. But the technologies are pretty similar. So it's C#, React. We use MongoDB, Docker, Gravity for authentication. So just a little bit about the different kind of problems that I've gotten to encounter through my software career. So when I first started working at Deswick, I was a little bit like, they still, a lot of mining companies, a lot of mining software still use WinForms, which is like nothing uses WinForms anymore. It's not even remote. It's not even like middle-aged. It's ancient. Like it's just so behind the times. And I was like, why on earth would this massive company with all these clever people do this? And it's because once you're down in the pit, you can't get internet access. So you can't use web tech basically in the middle of a mine site. So they tended to use installed applications, which if you're interested in the mathematics side of things, mining is a great place to go. If you're interested in using new tech, not always, because they do have to they have to deal with massive data on a computer that they can take into a mine. And they also need to be, you know, so it's a completely different problem to pretty much all the other software problems that you'll encounter. So most of the time, you're not going to have to deal with massive in-memory type data that you have to deal with in mining. The particular area I was working in was scheduling. So the scheduling of how the mine site was mined. And it was kind of mind-blowing how you could make the tiniest little tweaks in the initial conditions, and then but the end schedule would be completely different. So it was a real, you know, the butterfly flaps its wings in Tokyo and there's a hurricane in South America type situation, and very difficult to understand because often this sort of stuff. So it's a bit of a it was a bit of a joke when I was going through my early software engineering career that people would often say the code works really well, but it looks like it's been written by a mathematician, which is not a compliment. So it's like really clever, but nobody else can understand it. There's a lot of code like that in optimization software in these older companies where you go in and you look at it and you go, no idea what that's supposed to do. Nobody in the company knows what it's supposed to do. So you're kind of flying a bit blind sometimes. And they had a huge client base, which is great. So they were really successful. Their software is really, really good, but it meant that the customers had a very low tolerance for change. So if you saw something and you're like, that makes no sense, I'm going to change it, and it shifted the schedules by like half an hour, you'd have to roll that back. The customers would be like, nah, not having this. And then you have to start again. So there's like that whole, the problem of changing things when there's an established customer base is a different kind of problem. So some of the other problems, running dynamic algorithms on large data sets. So how do you know what's right? That's a massive problem in transport data. So you get timetables. So in the UK, for example, there's 300,000 stops in all of UK if you count all the bus and train stops, and you might have like 9 million trips running between them, and then with 3 million trips, 9 million walks between the close together stops, and you've got to somehow put that together and find the shortest path between things. But then you do that, how do you know you're right? You have to write another algorithm to test your algorithm. So generally speaking, you just have to hope for the best, and make sure you're really smart first time around when you write it. There's an increasing need to incorporate real-time disruption data. So I know the TransInfo app does this, where if you're if your train's running late, it'll tell you, so you can linger a little bit and leave home a little later, whatever. And that's fine if you're just doing something direct. But if you've got, often in the UK, you'll end up doing like, I think the biggest one I saw was like a 15-leg journey. So you'd walk somewhere, get on a train, get on a bus, get on another train, get on a bus. I think there was a hovercraft in there somewhere, and if that very first leg is broken, so you're going to get to that first stop too late to catch the first train, then everything you do from then on is out the window. So that's a big sort of problem in the industry. People like to travel in different ways, and that creates a lot of problems in terms of, I don't like the journey you gave me. I don't really want to have to go from St. Lucia to Toowong and change to 2 buses on my way. That seems stupid to me, which is fair enough, but mathematically it might be the fastest way to get there. So it's like, how do you kind of incorporate people and their preferences into a mathematical problem? So that's always the challenge. In England, the ticketing rules are really, really weird. So they've got this whole ticketing setup that breaks the triangle inequality. So that which I just love, because I'm a pure mathematician at heart, and so when I found that out, I spent 5 years trying to solve this problem. So if I go from here to the city, and then from the city to Capalaba, that might be cheaper than going from here to the city, and then separately from the city to Capalaba. So you've got all this weird stuff going on there. And of course, there's like off-peak travel and on-peak travel. And if any of you ever do go to the UK and catch a train, I highly advise you to book your tickets in advance, because the difference in cost is epic. So if you book in advance, you can spend like £40 for a ticket that you would, if you buy as a walk-on, will be £180. So to try and incorporate that into information that you give a customer and say, here's the cheapest journey, here's the quickest journey, here's the one that will take you past a pretty mountain, whatever. There's a lot of continuing problems there. A big push in all over the world at the moment, because there's lots of carbon offset targets most countries have to meet by 2026. So trying to promote sustainable travel. So giving the information so that people can choose to travel by public transport or EV or whatever. So that's come into it as well. And then all the customization that you could do. And then the big challenge, so in the real world, the data is always really terrible. So you get your transport data, and half the time you won't have an arrival time on a stop or a departure time on a stop, or your trip won't have any stops. I've seen that before. You get like a trip and you can't actually get on or off the vehicle, and you're like, why is this in the data? There's like, in the UK, every single stop has 4 different ways of identifying it. None of them are unique. So it's just, yeah, it's mayhem. So, and Brisbane data is not a lot better. So it's, you know, you're not going to have uniqueness constraints. You're going to have to work out fuzzy logic and all sorts of things. So some of the really fun things, or at least I think they're fun, hopefully you do as well. So I got to participate in a hackathon. So there's loads of hackathons in software engineering, and basically the idea is you go somewhere, you get presented a problem, you have 48 hours locked in a room or building or whatever. I was locked in the Berlin Transport Museum, I think, for 48 hours, and you can sleep or not. And then you present it at the end. So after 48 hours with no sleep, and you know, you've been working with people you only just met 2 days ago, and then you get up and do like a 10-minute presentation, and you've got to try and sell your idea and win the hackathon. It was really, really fun. Bit crazy, and I don't really remember much of it because I was so sleep deprived, but lots of fun. I did some work on, so with the UK data again, because it's such a massive data set, and they so with multimodal transport, you have all of those different, you know, that massive data set with 9 million walks and 3 million trips, blah, blah, blah. So it's really slow to look through, and most people on a website will disengage if they haven't had their response in like less than a second. If it takes 5 seconds, you're in trouble. They've moved away to another website. So trying to look through that kind of scale of data to give dynamic results in less than like a couple of seconds is very challenging. So I worked on an optimization technique for sorting through those large data sets, and got to lodge a patent on it, which is somewhere, I don't know where, but I can put it on my resume, which is nice. The graphics work that I looked at Deswick, that was really interesting, and kind of how complicated it is to build like a visual 3D model of something that A, works, and B, doesn't look like a 3-year-old drew it, is just, the challenge is huge. I love doing the congestion management stuff. That's really interesting. You can kind of, if you think about it in terms of little app with, you know, everyone kind of traveling along the network, and it going red when it's congested and green when it's not. And it's nice to think of being able to distribute people across that and make everything kind of orange instead of red. One of the fun things we looked at in my current work was incorporating augmented reality in our results. So we give back information to customers on how to get to a particular museum, and then there'd be like a World War II bomber that would like fly across their screen and then tell them information about where they were going and what they could see when they got there. Love exploring new algorithms. I used to hate being told that I couldn't do something, and now I love it. So now if I have an idea for something and I go and I say, oh, I think I'm going to make this happen, and someone says, oh, no, you can't do it, then I'm like, right, I'm going to prove them wrong. I'm going to make this happen. So I've quite enjoyed doing that. And often I find, I was talking to Yoni about this just before. So I'm a big believer in, if you're facing a problem and you think it's not, you're kind of stuck, is trying to flip your perspective. And I literally try and flip my perspective. So I do a lot of yoga, and I will do a headstand, think about the problem upside down, and then come back and do it. It's worked a surprising number of times, honestly. We did the software for the Commonwealth Games last year in Birmingham, and that was really exciting. So it was 2 weeks of rotating like on-call support, and they had made a commitment to have net zero games. And so as a result, they didn't have any parking offered at any of the venues. And then 2 months, no, not even 4 weeks before the event, the rail industry announced a rail strike. So nobody could get to any of the events unless they put parking in. But the rail industry said, these are the days we may have a strike. We're not going to tell you until 2 days before. So so we had to do this last minute scramble. Like they got some coaches to say they'd run on the days, and then I wrote what I refer to as the 2-day journey planner, because I had to write it in 2 days to deal with that coach data. And then we had all this like bespoke stuff in the software to say, if we say to switch this on, switch it on, otherwise switch it off. And we had to have all this different data in there to say, if there's a strike, use this car park. If there's not a strike, no car parks offered. So that was kind of very fun. A little bit stressful, but so the general problem space for pretty much everything I've done in software. So the mining problems were same, but different. So it's always generally optimization, often Dijkstra. With journey planning, you can get really great results if you add the A-star algorithm onto that. There's another algorithm that you can, like, it's open source and OpenTrip Planner use it, so you can like download their code and look at it, called Raptor. There's CSA, which is connection scan algorithm. Google use something called transfer patterns, but they're unsurprisingly a little bit tight-lipped about it, but there is some information out there about it. And then it's just a constant battle of, we need it to be fast because it's a website thing, but we also need it to load real-time data really quickly. You can make things really fast if you pre-process them and have everything stored in memory, but then it doesn't play well with the real-time updates. So if I've already worked out that in 6 weeks, the best way to get from here to Indooroopilly is going to be this, that's then going to be very difficult to update in real time. So you have to get it's a real fine line between dynamic versus pre-processed information. So just a little insight into my day as a software engineer. And this is pretty much across every job I've had. So pretty much every company these days uses one of the agile methodologies. So have you guys learnt much about that? Yeah. So you have it, that comes with the whole suite of meetings that can go for ages, but are usually really valuable. And then you basically designing, writing, reviewing, testing your own and other people's code. More and more software engineering jobs will involve some knowledge of DevOps. So you need to be able to work a little bit with some of the build automation and the continuous integration and the continuous deployment. But again, that'll depend on how big the company is. So a very large company will often have like a release team and they'll handle a lot of that. I think it's really handy to be able to do that stuff as well, just because if you have a great idea and you want to build something yourself, if you can do every single step yourself, you don't have to rely on anyone else. You can just, you can make your amazing idea and make big money. And often everything's moving towards cloud-based microservice architecture, which basically means, so in the early days of software, everything was like this massive monolithic structure. So you'd send something in, you'd get something out. You couldn't just ask for a bit of information. You had to get all of it. It was all or nothing. So for example, in the case of a journey planner, you would send in your from location, your to location, and you would always get your journey. You would always get the kind of lines, like the lines on the map. You'd always get the fares. If you just wanted the fares, you couldn't just get that. If you just wanted the map lines, you couldn't just get that. So what's happened now is the kind of software industry has moved towards making lots of little things that just do one thing, which is great when you're just working with that one microservice, but trying to get them all to talk to each other and making sure they're all synced is a different challenge again, and then deploying them all. So it's, I guess, some of the complexity has moved out of the software itself and into the deployment. So just a little, like, this is what I actually work on now. So this is our like web application thing. I don't know why I have to wave my hands around so much when I say that, but so you can put in, the usual journey planner type stuff. But one of the things that it gets used for, which I think is pretty interesting, is when you have areas of of a city that aren't actually on a map properly. So this is it's a festival that they have in the UK called the Godiva Festival, and it's just in a park. And when you have, I don't know if any of you guys have been to festivals that are in big parks, and you've got no idea where the toilet is or how to get there, and you've got no idea how to get to the bar, you don't know where stage 1 is or stage 2 or stage 3. So the idea of this is that they can tell us that information, we'll put it on the map for them, and then we'll create a little website that they can give to their users, and their user will be able to go, oh, okay, look, cool, I'm here. I need to walk up there to get food, or I need to walk up there to use the amenities, or whatever. So it just allows a little bit more kind of richness of information. And yeah, this is what the map then looked like. So if you try to do this in Google, it would kind of skip the bit inside the park. It would just tell you had to walk all the way around the park, and it wouldn't actually get you to where you needed to go. One of the fun kind of projects we worked on, so we do loads of R&D projects, which is one of the things I love. So I love lots of software companies will do some R&D, and the R&D stuff is, I think, super fun. We did like a project to try and get an app that would interact with EV charge points end to end. So you could actually like sit at home, plan your journey. This EV charge point is available. I'm going to book it for 3 o'clock today. I'm going to go there. I'm going to start my session using my app. I'm going to stop my session using my app, and then I'm going to pay for it using my app. And so we did this research project, and the conclusion of it was that the EV industry is not ready for this app. So the test EV charger was sitting on someone's desk in Ireland. And every time we had every time we had to test it, I would have to like get on a Zoom call with this guy. So I'm in Brisbane, he's in Ireland. So the time difference is not anyone's friend. So I have to ring him up on Teams and say, can you please manually start the EV charger on your desk so that I can see if my app is working? And so on. But it was still interesting. And you could kind of see how if they upgrade the hardware on these machines, then some of this stuff will be really very possible and very cool. So things to consider if you're looking to go into software engineering and probably other non-academic pathways after you finish your degrees. So in software engineering in particular, data science is huge, really, really huge. So everyone wants a data scientist. Everyone has loads of data and they want it to be data scienced, but nobody actually knows what they want done with it. So if you can find out a way to work out what these companies want, that'll be a massive selling point. So I think at every company I've worked at, we've had data scientists and we've just gone, here's some data, tell me about it. And they've just gone, what? Which is fair enough, I would too. But if you can somehow look into that data and work out what the person asking you wants to know, that would be pretty magical. One of the things that I have found very interesting through my career is the different types of thinkers. And I've kind of summarized it as linear versus lateral, but there's heaps of different kinds. Like everyone learns in different ways and thinks in different ways and problem solves in different ways. But where I always found it fascinating. So when I was at Silverell, I worked with lots of people who are quite linear thinkers, and I'm quite a lateral thinker, and I jump around like a flea, and I have no idea how I've gotten from one point to another. But where I've gone makes sense and it works. But it doesn't make sense it never made sense to anyone else I worked with. And I would get quite frustrated because I'd be like, so we can do this thing. I know that we can do this thing. And they'd be like, how do you know that? And I'm like, I don't know. I don't know how I know that. And after many years, I learned to kind of, I guess, linearize my thoughts and make them into logical steps. I mean, they were logical steps to me, but logical steps to other people. And then at the company I'm at now, nearly everyone there is a lateral thinker. So I'll say all of these zany things and they'll go, yeah, I think that too. And it's quite kind of interesting to see that if you have a group of people who all come to conclusions in a similar way, it's not necessarily better or worse, it's just different, but you've got to kind of manage if you want to get out of it what a particular thing, you need to kind of work out how they are hearing what you're saying and then kind of reword it, basically, restructure it. object-oriented coding. So Julia's not really, is that right? Or sort of?
As notions of this
Yeah. Yeah. So it's object-oriented coding is a whole kind of art form in itself. And you've got to think a lot about how you're going to structure things. And often it makes sense to make them match the real life data that you're looking at. But I found that probably one of the harder things coming from maths, because I just kind of, I don't know, I just write one big log algorithm and then I go, oh, okay, now I have to turn this into classes and objects. So the more you can expose yourself to it, if you're planning on doing any software engineering or coding, the more you can expose yourself to it early, the better. Understandable code. So this is the whole kind of point I made earlier about, people would always say, oh, your code looks like a mathematician's code. And I'd be like, well, I am a mathematician. So, but it's good if other people can understand it. And sometimes it's just as easy as making the names descriptive. When I first started coding, I think the code base I was working on, it was old C code, and there was a restriction on the number of characters a variable name could be. So everything was just cut off at 4 or 5, and nothing made sense as a result. But we don't have that restriction anymore. So you can make your variable names like as long as the line. And if that makes sense and makes it easier to understand, then why not? Loads of transferable skills. So as I told you before, I didn't actually know. I remember my first day at work, I had to call someone to find out how to switch my computer on because I had a PC and I'd never had a PC before. And then a week later, I was fine. So everything you're doing day to day in your degree, you're learning how to learn. You'll be able to do all of this sort of stuff, no problem, if that's what you want to do. So it's the investigation, it's the learning, it's the, oh, I don't know how to do this. How do I work out how to do this? That's what employers want. Collaboration. So I think you guys do more group work now than I did when I was at uni, but I think I did one group project my whole degree. So it's working in a team is a different thing. So you'll have people in your team you love, you'll have people in your team that you really, really the opposite of love, and you'll just need to work out a way to communicate and get along okay with all of them, and try and, I guess, allow the challenges to help you learn. So I used to get really frustrated when people I felt patronizing or overly kind of challenging, like, oh, you don't know what you're talking about, sort of thing. And now I don't always succeed depending on the day, but now I try and let it wash over me a little bit more and just allow it to become more of a, okay, why are they saying this? What am I doing? That's is there anything I can do to make myself seem more convincing? If there isn't, I just let it go and just let my work be the proof. And it pretty much always is. Code style, there's lots of different correct ways. Most companies will have a coding standard that you'll have to follow, even if you think it's really dumb. Some companies won't, but it's helpful if you do, because again, that makes it easier for other people to understand. There are some kind of language-wide conventions, and they vary from language to language, which can make life difficult. So it's really easy to understand. So all programming languages are logically the same, like an if loop is an if loop and a for loop is a for loop. And the complicated things, I think, are very easy to switch between languages. The things that are harder to switch between languages are the simple things. So it's do you put a capital letter at the front of a variable name? How do you do a string comparison? So string comparisons vary from language to language. How do you write to a file? That varies from language to language. So it's the simpler things, or the things that I think should be really simple. Those are the things that you'll go, oh, I have to actually think about how to do this. Because I was for a while working in like 4 or 5 different languages at once. And it was one week in particular, and I was going between Java and C#, and Java and C# are the ones that have the string comparison different. And I'm like, why is my code not working? I'd put an equals in the wrong spot, and that was it. But yeah, so that's it. I've just talked very, very fast, and I feel like for a very long time. So hopefully someone has some questions for me. Anything at all. Yep.
So I was a bit late, so I want to miss the start, but do you ever really consider, you do work at a company now, do you, like,
Yeah.
work for yourself?
No, yeah.
What about doing your own thing and starting something new?
I have, yes. And the company I'm at the moment is so small that I feel like if that's something, it's kind of convinced me not to. But it's been interesting in that I get to do a little bit of everything. And if someone's, because it's so small and because it's really kind of pedal to the metal kind of stuff, I've gotten to kind of understand what all the different bits and pieces do. I think the tricky thing about starting something on your own is, for me anyway, and what I've kind of realized is you've got to make some really kind of ruthless decisions. And I find that a bit stressful. So if someone's a poor performer, for example, if you run the business, you can't keep them on, even if they're really nice and even if they're having a tough time or whatever. Like, those sorts of decisions are things that I would struggle with. And then also all the kind of the selling, like, you've got to be really persistent and you've got to be kind of annoying. And nothing in my maths background has trained me to go out and go, let me sell you this thing, let me sell you this thing. So I guess it's a very different skill set. But if you had like someone that you could work with on that, yeah, it'd be a great thing to do. It's very, very fun. Yeah.
Do you know a favorite project to work on, or like task?
There was one that I did where it was basically so it was a ticketing problem, and it was a customer that wanted to know, they wanted to display like a 90-day calendar of all the cheapest ways to get between. So you could say, I want to go from like Oxford to London, say, and it would give you a 3-month calendar with the cheapest fare on each day of that calendar in less than 90 seconds. So that was really tricky because I had to use, and I really enjoyed that because I got to use in software algorithms, but I also got to use kind of like out of the algorithm. So you know, like I can solve these two bits of the problem at the same time. So I have this running in this microservice and this running in that microservice. And at the same time as those two things running, I'll have this thing running along here. And it was kind of like a puzzle, like a jigsaw puzzle. So I really enjoyed that. Yeah. Yep. Oh, my PhD was in quantum superalgebras. Yeah. So I'm not sure what the industry job in that would be, but I'm not doing it. Yeah.
You wish that, like, you had the opportunity to keep mixing around on mathematics, or you feel happy that your career involves a lot of software engineering as well?
That's a great question. So I always thought I would become an academic. And I never really thought I would enjoy like doing a regular job, I guess. But what I found, so when I did my PhD, I did enjoy doing my PhD, but the kind of payoff, it takes such a long time to get any feedback on a PhD. And I found that really tough. So, you know, essentially a 3.5-year project. And then after that, I found out whether I'd done all right or not. What I love about software engineering is the problems are a bit smaller and I get feedback more frequently. And I like that. So I like to be able to, I like to have a few more highs over a 3-year period than one. So for me, that worked really well. And I think as well, I never found, when I was in academia, I never found a research project that kind of lit me up. Whereas a lot of the stuff I do you know, even on a day-to-day basis, a lot of the stuff I'm like, this is really cool and I'm really enjoying this. And I've ended up enjoying software engineering a lot more than I thought I would. And I mean, I'm particularly passionate about the industry I'm in at the moment, which is why I came back to it after the stint in mining, but I still enjoyed the mining work. Not as much as I enjoy this, but I still enjoyed it. So I clearly like software engineering more than I thought. And there's enough maths in it to keep me interested. So yeah, I don't regret it, no. Yep.
Like from your experience, would you say just first coming out of uni, getting your first job, would you go to get a job at a small company where you can have a lot of that, I guess, flexibility, or a big company?
So for me, a small company. The advantage of a big company is that if you're someone who likes certainty and structure, a big company will offer you more of that. So I don't know, when I start work every day, I've got no idea what I'm going to be doing, and nobody knows, because if something comes in that's urgent, you've got to switch streams. I love that, but some people really don't like it. And sometimes I have to work on 10 things at once, and I get a bit like, oh, this is, I think 8 is my limit. And the other thing is, big companies tend to be better about managing work-life balance. So if you have other things that you like to do at specific times, a bigger company can be better for that. Smaller companies, it can be really variable. Like I can do a pretty light on week one week because there's not a lot happening. And then the next week I've got the Commonwealth Games. So I work from like 9 a.m. to 1 a.m. every day for 2 weeks. So it's very up and down. I worked part-time for many, many years after I had kids, and I couldn't have worked at a startup when I had little kids. But now my kids are older, so it's great. It works well. So they're both good in different ways. Yep.
Having never done any like coding programming in your experience, what language did you find most difficult to code?
Perl. I probably never really learned how to code in Perl properly, to be honest. Of the ones I know pretty well, I mean, C++ is way harder than C#. And I would even now, I can write C++ code really well, but if I had to do an interview in a C++ job, I would probably struggle because I didn't learn it formally. And although, there's the classic question that apparently they always ask in an object-oriented coding interview, which is, when would you use inheritance and when would you use polymorphism? I can never remember the answer to that, even though I would always in practice do it right. So I can write really good C++ code, but if you asked me to explain what I was doing, I would struggle. I don't have the terminology at my fingertips. C# is, because it's managed, you don't have to deal with any of the memory management. It's a lot kind of simpler. So it's just kind of like reading a book. If you think the function should exist, it'll exist, and you'll press dot and it'll autocomplete for you. And then you can just get on with the stuff that you're more interested in. C++ will do that too, but you have to manage the memory, and that's tough. Oh, yes.
So there's types of behavior. So one is you're going to use a function, and let's say a git subcommand you've never used. And one way is to look at Stack Overflow and to get the minimal solution. Is that different ways to read the docs for 15 to 20 minutes. Which are you?
It depends how important. It depends on what I'm doing and how important it is. If it's really important or performance critical or memory critical, I read the docs. Well, that's not strictly speaking true. So you learn quickly. Stack Overflow, there's certain names on there that if they've made a comment, then you can take that as pretty much truth. I think John Skeet is one of the guys who, like, if he's written something on a Stack Overflow page, I'm like, yep, must be true. But there's a lot of, I mean, I'm sure you've all met these people. There's a lot of people who sound so authoritative in the maths world and in the software world, and they actually have no idea what they're talking about. And you think, you meet them and you talk to them and you're like, wow, they sound so convincing. Why don't I understand what they're saying? And then you realize it's because they're talking rubbish. And there's plenty of people like that on Stack Overflow. Whereas the MSDN docs, very hard to get your head around, but it's, you know, they're just so dry, but they're always right. So, yeah. But if it's, you know, if it's like, how do I write this thing to a file? I just, yeah, Stack Overflow, whatever. It doesn't matter that much. I haven't, but a couple of people at work have. And I read a few interesting things about using ChatGPT to do complex maths and how it doesn't work at the moment, not because ChatGPT can't do the maths, but because it doesn't understand the question. Which, you know, makes sense. So yeah, a couple of people have asked me if I'm worried about losing my job to AI. And I'm like, well, maybe I won't have to write the code in 10 years' time. Maybe I won't be required to type on the keyboard, but someone has to come up with the problems to tell the AI until the AI take over the world entirely. But then that's okay. I'll just read a book, chill, you know. But yeah.
Let's thank Mehta again. Last year, you might see Mehta's recording on YouTube from 2021. So that was before those Commonwealth Games.
That was, yeah.
Then in 2022, the Queen passed away. So we had to reschedule, but this is the third year. Okay, so thanks again. Okay, everybody. Thank you.
Thanks.